Information that they give us in these 6 graphs are for the first 5 questions on this practice test. So we're going to need to know what to do with all of these. So the first question, we're going to find the quadratic with the highest vertex. So we need to remember what vertex means. Vertex is the very high point or very low point for the graph. So if we or we can remember it's the formula x is equal to negative b over 2a, and then you plug it back in to find your y. So if we look at g of x is in standard form. So in order to find the vertex, we're going to be using the formula, and then we're going to plug in the numbers. So from this equation, a is 3 and b is negative 6. So negative b would give us positive 6 over 2 times a. 6 divided by 6 is 1. And to find y, we're just going to take that 1 and plug it in for x to our equation. So we have 3 times 1 squared minus 6 times 1 plus 4. Order of operations, we're going to square the 1 first. 1 times 3 is 3. Negative 6 times 1 is negative 6. Bring down positive 4. And then adding and subtracting left to right. 3 minus 6 is negative 3. Negative 3 plus 4 is 1. So my vertex is 1, 1. But since they're talking about the highest vertex, we're actually talking about the y value. So we're looking at the y value. So far, I have that g of x has a y value of 1. Then when we look at m of x, it's the graph. So this one's easier to read. The vertex is here at negative 2, 4, if we correctly read those labels. And that means the value is here at 4. So let me make a note of this. We're looking at the y value and the vertex. Okay, f of x is this in standard form. So again, I'm going to look at my formula. Negative b over 2a. A is 1 and b is negative 10. So opposite b will give us positive 10, and then 2 times 1. 10 divided by 2 is 5. And then again, I'm going to take that and plug it back in. So I have 5 squared minus 10 times 5 minus 4. 5 squared is 25. Negative 10 times 5 is negative 50. And negative 25 minus 4 is negative 29. So this has a vertex at 5, negative 29. Puts you really far down the graph. So negative 29. And then h of x is this graph right here. So if we look at the vertex, we're at 4, negative 1. So my vertex value here would be negative 1. So we want to look at the highest vertex. That would be part B. So that's how we get B for our answer. Okay, number 2 is asking which of the quadratic functions has imaginary roots. So what that actually means is that if we have imaginary roots, it means on a graph, the graph does not cross the x-axis. It also means in terms of algebraically, using the discriminant, that there are no real solutions. Okay, so no real solutions means it will have imaginary solutions and doesn't cross the x-axis. So if we look at f of x, it's in standard form, so I'm going to go ahead and do this algebraically. I'm going to use the formula b squared minus 4ac. So I'll do that in a different color. I'm going to look at f of x first. So b squared minus 4ac. I'm going to plug in b is negative 10, and then c is negative 4, a is 1. And so I'm taking those 3 from my f of x equation and plugging them in. So b squared is going to be negative 10 squared minus 4 times a times c. And then I'm going to simplify this. Negative 10 squared is 100. Negative 4 times 1 is negative 4. Negative 4 times negative 4 is positive 16. So I get 116 for my discriminant. So since this is a positive number, then I know this means I have two real solutions. If you have real solutions, you don't have imaginary solutions. So I'm going to cross this one out. So now we're going to look at g of x. G of x is this equation. So I'm going to use a is 3, b is negative 6, and c is 4 to find the discriminant. Same thing I did for f of x. So g of x, b squared minus 4ac. I have b is negative 6, so negative 6 squared, minus 4 times a times c. Negative 6 squared is 36. Negative 4 times 3 is negative 12. Negative 12 times 4, negative 48, or minus 48. That's going to give me negative 12. Since this is a negative discriminant, it means that I'm going to have 0 or no real solutions or real roots, which means I do have imaginary roots. So I'm going to mark B as my first answer. Then we're going to look at h of x. H of x is this graph, and since it does not cross the x-axis, it means that it does not have any real solutions. No real roots, no real solutions, which again means that we have imaginary. So my next answer is going to be h of x. Again, if it doesn't cross the x-axis, then it has imaginary roots. So I'm going to circle h of x for that one. Then I have j of x, which is this, which I'm going to go ahead and just do a quick sketch of what this is. This is in vertex form. So the vertex is negative 2 comma 0 because we switch the sign when we take out h, and then the k, there's imaginary plus 0. So negative 2, 0 would be my vertex, and then it opens upside down. So that would be a quick sketch of that. That does cross the x-axis. So since it does cross the x-axis, it has a real solution. So there's no imaginary on that one. So I'm going to cross that out. J of x has a real solution, not imaginary. And then m of x is this graph. M of x, again, does not cross the x-axis. Since it doesn't cross the x-axis, it means that there are no real roots or no real solutions, which means we do have imaginary. So my next answer is E, m of x. And then my final function is k of x. They give me a table, so I'm going to go ahead and draw a quick sketch of what those points would look like. So negative 3 would be my first ordered pair from the table. Negative 2, negative 1, negative 1, 0, 0, comma 4, somewhere up here, 1, comma 0, 2, comma negative 1, and 3, negative 3. So this is what my parabola looks like. And I see that it does cross the x-axis, which means there is, in this case, two real solutions or two real roots. So there's no imaginary whenever there's real. So my answer is not k of x. I have three answers: g of x, h of x, and m of x. Again, imaginary roots in terms of a graph would mean it doesn't cross the x-axis. And when you use the discriminant, you would get no real solutions or a negative answer. All right, part 3, which parabolas have at least two real roots? And that we've already kind of gone through. Roots is just another word for x-intercepts. And it's another word for solutions. Those three are all going to mean the same. So if we look at f of x, we did the discriminant for f of x, and we found out that the discriminant was a positive. So we found out there's two real solutions. Again, solutions mean roots. So my first answer is going to be A. Looking at g of x again, I got that negative number, meaning no real solutions. H of x is this one. It never crossed the x-axis, so there were no real roots, no real solutions. And then j of x was this one with only one real solution or one real root, but they want two, so we're not gonna pick that one. And then we saw k of x in our quick sketch of these ordered pairs does cross the x-axis twice, so we say that it has two real roots or two real solutions. Okay. Number 4. Is asking which one of these graphs that we have on the front could be used to model a ball that is tossed in the air. And they're assuming the x-axis represents the ground. So what they're looking for is on the x and y-axis, the x-axis is going to be the ground. So if you picture a ball being tossed, they're looking for a negative parabola that goes over the x-axis. So it has to be a negative parabola opening down, and it has to be above the x-axis because when you throw a ball, you're above the ground. And it shows if you're here, you throw the ball, gravity brings it back down to the ground. So we're going to look at these 5 graphs. F of x, we're going to go back to the front. F of x, if I were to do a quick sketch of this, let me do this in red. If I do a quick sketch of f of x, it would look like this. This is my x and y axis. This would have a vertex at, 5, negative 29, so way down here. And it opens up because of the positive a value. So if I did a quick sketch, this is not what they're looking for because it doesn't open down. It opens up. So f of x is not going to be what I'm choosing. G of x is here. G of x, if I did a quick sketch, I would have a vertex at 1, 1. And then this is a positive a value, so it opens up. Again, opening up isn't going to model a ball being thrown in the air, so we don't want to choose g of x either. H of x, we're going to look at next. This does open upside down, but again, if you pictured the x-axis to be the ground, that means you're throwing a ball underground. That's not what they're looking for. Again, it has to be above the ground. So I'm not going to choose h of x. Part D, j of x, I am going to see the graph I already drew. Again, this does open down, but never goes above ground, so it doesn't make any sense. We're not going to choose j of x, but k of x is what we want to choose because it's above ground and it opens down. So this part right here would be modeling throwing a ball. You start here, the ball goes in the air and drops over here. So f of x, or not f of x, k of x is going to be our answer. So I'm going to choose k of x. All right. For the next one, for what values of x are f of x equal to j of x, what I'm going to do is I'm going to go to the front side and I'm going to copy down each of those equations. Okay. All right, so f of x is 10x, or is, x squared from the front side again is right here, the front side. X squared minus 10x minus 4. And that's equal to j of x. So j of x, again, from the front is this equation. So I'm setting these equal to each other, just like what they're telling me to do. So now what I'm going to do is I'm going to try to solve for x. So when I'm doing this, I have a quadratic equation. So I'm thinking of my different methods for solving. Factoring is going to always be my easiest method to solve. So I'm going to try to set this up so that I can factor. So what I'm going to do is I'm going to get rid of these parentheses by squaring the x plus 2. So when I square x plus 2, it's going to look like this. Make sure you keep that negative out in front. We're going to take care of that after we're done squaring. So from here, I'm going to copy this down. X times x is x squared. X times 2 is 2x. 2x times 2 is 2x, and 2 times 2 is 4. Then I'm going to distribute, or I'm not going to distribute. I'm going to combine like terms. And I get x squared plus 4x plus 4 now in my parentheses. Now I'm going to distribute the negative to the inside. So I'm multiplying this negative 1 to the inside of my parentheses. So I have x squared minus 10x minus 4 is equal to negative 1x squared. Negative 1 and 4x is negative 4x. Negative 1 times 4 is negative 4. Again, I'm trying to factor, so I'm going to move all of the terms to one side of the equal sign. I want to get rid of the negative a term because that makes our factoring a little more difficult. So what I'm going to do is I'm going to move all of these three terms over here to the left side using inverse operations. So I'm going to get rid of the negative x squared by adding x squared. Remember, that's going to be added with the x squared term over here. Then I move negative 4x by adding 4x to both sides. Then I move over negative 4 by adding 4 to both sides. And then I'm going to add down, and I get x squared plus x squared is 2x squared. Negative 10x plus 4x gives me negative 6x. And then negative 4 plus 4 cancels. And then the rest of this cancels. So I'm left with two terms that I need to factor. When we have two terms like this, we want to factor using GCF. So I'm going to divide out the largest number possible from 2 and 6. That's going to be 2. And then the greatest variable is going to be x. So I write down that GCF, open parentheses, and do the division. 2x squared divided by 2x. 2's cancel. X squared divided by x is x. Negative 6 divided by 2 is negative 3, and these x's cancel. You can always check your work by distributing. 2x times x is 2x squared. 2x times negative 3 is negative 6x. That's how you know you factored correctly. So we know that when we're factoring, we want to take the factors and set them equal to 0. So I'm going to do that over here. I'm going to set each one of these factors equal to 0, and I'm going to solve. So my first factor, 2x equals 0. My second factor, x minus 3 equals 0. And then I solve. I divide by 2 to both sides. 0 divided by 2 is 0. And x is equal to 3. I'm not going to plug these back in because they just wanted the values of x. So my answers are 0 and 3. Number 6, we're given the graph of g of x, and we want to know what the vertex would be for this function right here, this transformation. So again, we need to know that this is our vertex for g of x to start. So we're going to focus on translating that function or applying the transformation to that vertex right there. So when you have g of x and you have minus 3 inside the parentheses, we remember that that means to translate our function 3 units to the right. So because it's negative, remember you think of switching the sign when you're inside parentheses, so it actually means move 3 to the right. And then this negative 1 out here means translate down 1. So I'm going to take this vertex, which starts here, and I'm going to translate it 3 to the right and down 1. And then just draw a quick sketch of that graph. So my vertex for this transformation would be right here at 1, 1. Number 7, 8, 9, 10, and 11 all focus on this graph. So we're giving you the traveling distance, where all of these numbers represents the miles, the distance in miles, and then the time in hours is on the x-axis. So we're going to write the equation of the graph in function notation. So remember the equation for a line, and I'm going to use function notation, which means instead of writing y, I'm going to write f of x. It's equal to mx plus b. So what we're going to need to do is figure out what our slope is from this graph and what our y-intercept is. So I'm going to go ahead and use x1, y1, x2, y2. These ordered pairs are going to help me find my slope to start. So I'm going to use the slope formula, y2 minus y1 over x2 minus x1. And I'm going to plug in the numbers from the ordered pairs. So y2 minus y1 So 0 minus 360 over x2, which is 6, minus x1, which is 0. So when I simplify that, negative 360 over 6, negative 360 divided by 6 is going to give me negative 60. So I know my slope. I'm going to take that negative 60, plug it in right here for slope. Then I'm going to find out my y-intercept by looking at the graph where it crosses the y-axis is right here at 0, 360. So my y-intercept is 360. So what I'm going to do is I'm going to take my slope, negative 60, my y-intercept, 360, and just plug it in to that equation that we wrote here. So function notation, we're writing f of x instead of y is equal to negative 60x. Remember, the slope goes in front of x. And then my y-intercept, positive 360. That's my answer. Number 8 is asking, after 4 hours, how many miles do you have left to travel? So if I'm at 4 hours, which is here, I have still 120 miles left. So right here, I meet at 4, 120. So my answer is 120 miles. So we need to be careful and make sure we understand each of these is counting by 40, 80, 120, 160, and so on, based on the labels. How long did it take you to travel back home? So again, this is traveling home after a vacation. So this is where you're starting and then getting back home over here. So it takes 6 hours to travel back home. So 6 hours. And then we're going to interpret the slope. So interpret the slope. We're going to say, as each hour increases, so remember our slope is negative 60. So as each hour increases, the slope or the distance to travel decreases by 60 miles. So as each hour increases on here, we're decreasing by 60 miles, the distance left to travel. And then what does the y-intercept represent? The y-intercept here represents the starting distance to home, so where we started. So we can write that down, the starting distance to home. Or you can say the miles away from home you are on vacation. So either one of those would be a good interpretation of the y-intercept. Okay, number 12. We're going to look at each of these systems of equations and we are going to put them in the correct spot. Either they have no solution, one solution, or infinitely many solutions. So we're going to determine where these 4 go. So what I'm going to do is I'm going to go through each one and I'm going to start to solve it to come up with answers. So I'm going to solve each one. For part A, I'm going to use the substitution method for solving because x is isolated. I'm going to take 4y plus 1 and plug it in right here for x. When I do that, it's negative 3, then parentheses, replace x with 4y plus 1 plus 12y is equal to negative 3. When I continue to distribute, I get negative 12y minus 3 plus 12y is equal to negative 3. When I combine like terms, negative 12y and positive 12y, those actually cancel out, and I'm left with negative 3 equals negative 3. Since this is a true statement, we call this infinitely many solutions. So I'm going to put A over here under infinitely many solutions. Part B is this system right here. Since these are both in standard form, I'm going to use combination. So I'm going to try to eliminate a variable. If I multiply this by 3, I'll get 9x to cancel out with negative 9x. So I'm going to show that work up here. I'm going to distribute 3 and multiply 3 to each term for this first equation. I get 9x minus 15y is equal to 33. And then my second equation I'm just going to copy down, and then I'm going to cancel out. 9 and negative 9x go away. Negative 15y and positive 15y go away. We're left with 0 is equal to 43. That is not true ever, and I have nothing to solve for, x or y. So this is when we have no solution. So B is no solution. For C, I don't have this isolated or in standard form, so I'm going to go ahead and put this in standard form before I start. So what I'm going to do is I'm going to move this 6 to the other side of the equal sign by adding 6. So I'm going to rewrite this first equation. It'll be 4x minus 14y is equal to 6. And then my second equation, negative 2x plus 7y is equal to negative 3. So using combination, I'm going to multiply this second equation by 2. By 2, I'm going to rewrite this top equation that doesn't change, and it becomes 4x minus 14y equals 6. And the second equation, after multiplying by 2 to all of the terms, 2 and negative 2x is negative 4x, 2 times 7y is positive 14y, and 2 times negative 3 is negative 6. So now when I combine or add down, 4 and negative 4x cancel, negative 14y and 14y cancel, and then 6 and negative 6 cancel to leave us with 0 equals 0, which again is a true statement, which means infinitely many solutions. The reason why both of these cancel out is because they're actually the same equation, and they're the same line. So they're the same line, they overlap completely on a graph, meaning infinitely many solutions. And then our last system, part D, 4x plus 3y equals negative 5, and negative 3x plus 5y equals 11. And I'm actually going to save some room. I'm going to think about how I want to cancel out a variable. So I have a 4 and a negative 3, so I can get a positive 12 and a negative 12. To get the positive 12 on the top, I would multiply by 3. To get the negative 12 on the bottom, you would multiply by 4. So I'm going to do that over here. 3 times 4x is 12x. 3 times 3y is 9y. And that's equal to 3 times 5, which is 15. 4 times negative 3 is negative 12x. 4 times 5 is 20y. And that's equal to 4 times 11, which is 44. And then I'm now going to combine. And these cancel. 9 and 20 give me 29y. 15 and 44 give me 29. So when I divide and solve for y equals 1. So now I can see that I'm going to have one solution, because when I take y and plug it back in to get x, that gives me one solution. Number 13 is graphing a system of linear inequalities. So we remember when we see the inequalities, instead of equal signs, we will be shading. So what we want is to write these in slope-intercept form so that we're able to graph them. This is already in slope-intercept form, y equals mx plus b. So I'm going to graph this one first. This is my y-intercept. I'm starting down at negative 4. And then I have a slope of 2 over 1. So from this y-intercept, I rise 2, run 1, rise 2, run 1, and do that across my entire paper. I'm going to be drawing a solid line because of the underline in the inequality, telling me this is a solid line. So through these points, there's my solid line. And then this says greater than. That inequality says greater than, so I'm going to shade greater than this line. I'm going to shade above it, so I'm going to draw some arrows for my shading. So now I'm going to do the same thing over here with this inequality, except this one is not ready to be graphed. It's not in this slope-intercept form. So what I'm going to do is I'm going to get this in slope-intercept form by adding x to both sides. When I add x to both sides, I have 2y. Those cancel out. Copy down the inequality, and then I have x plus 2 over here. And those don't combine, you just write them next to each other. To get y by itself, we're going to divide all of our terms by 2. So I'm left with y is less than or equal to 1/2 x plus 1. 2 divided by 2 is 1. And there's a 1 in front of this x. So I'm going to graph this. I start up 1. There's my y-intercept. My slope is 1 over 2, so rise 1, run 2. 1 over 2, 1 over 2. Same thing in this direction. And then I'm going to draw my line. Again, a solid line because of the underline in the inequality. This inequality is less than. Because it's less than, you're going to shade underneath. In a system of inequalities, you shade out of the 4 regions that are created by the 2 lines intersecting. You shade where the arrows intersect. So our arrows are intersecting here. So this shaded region is showing our solution to the system. Number 14, we have this word problem. We're spending $96 on food for a party. You buy a total of 10 items. You're buying burgers that cost $12. So burgers are going to cost $12 for each package. Buns are going to cost $8 for each package. And with all of these numbers, we can write a system of linear equations. So my first equation is going to represent the amount of money that he spent. So it's going to be $12 for each burger, for each package of burger, and then $8 for each package of buns, for a total of $96. So again, I was able to put these 3 numbers that represented the money or the cost into one equation. Then our other number talks about the number of items. So it's going to be the total number of burgers plus the number of buns for the total of 10 items. So that would be our system. So let's go ahead and identify, we let X be our packages of burger. Number of packages of burgers. And then Y will be our number of packages of buns, so that we know what we're talking about when we solve for X and Y. So what they want us to do next is to solve the system by graphing. So I'm going to put each of these in slope-intercept form, y equals mx plus b, so that I can graph. So I'm going to start with this first equation, 12x plus 8y equals 96. So I'm going to try to get y by itself, so I'm subtracting 12x to both sides. I get 8y is equal to negative 12x plus 96. Then I'm going to divide everything by 8. And I get y equals, let's simplify this fraction by dividing 4, top and bottom. Negative 12 divided by 4 is negative 3. 8 divided by 4 is 2. So I simplified that fraction, made it negative 3 over 2, x. And then 96 divided by 8, if you can't do that in your head, you can just do that work right here. 8 goes into 9 one time. 1 times 8 is 8. Subtract, bring down the 6. 16 divided by 8 is 2. So plus 12. So I'm going to go ahead and graph that first. I'm going to start up at 12. My slope is down 3 over 2. Down 3 over 2, and I continue doing that across my graph. And then I use this to draw my line. So there's my first line for my first equation. The second equation, x plus y equals 10. This one's a bit easier to get y by itself. We're just subtracting x to both sides. Y equals negative x plus 10. So I start up at 10. My slope is negative 1 over 1. So from here, down 1 over 1, down 1 over 1. And there's my second equation graphed. When you look for the solution of a system of equations, you look where they intersect on the graph. So my solution is 4, 6. It's where they intersect, 4, 6. Part C, we're going to interpret what this solution means. We wrote up here that X would equal our packages of buns. So 4 talks about our packages of buns. And then 6 is our Y. So the Y talks about, X talks about the packages of burgers, and Y talks about packages of buns. So based on that, we have to interpret our solution that you bought 4 packages of burgers, because we let X be our burgers, and 6 packages of buns, again, because we let Y be our buns. All right, 15, 16, and 17 go together. So we're going to use these graphs. Number 15 says we want to match the function f of x equals absolute value of x plus 2 with one of these graphs. So our function here with plus 2, we remember we're going to translate the parent function up to. So when you look at these graphs, the parent function on part A is up to. This one is translated right to, this one is down to, and this one is left to. So we're translating up to. Our answer is A. We went up to for our vertex. And I can show you that it's because your parent function, absolute value of x, is here at 0, 0 for a vertex. All right, number 16, we're going to match this function with the graph above. We remember if it's inside the absolute value or inside parentheses, that number means go left and right. Because it's a positive 2, it means to go left 2. Remember, when you're inside parentheses or absolute value, you kind of think of changing that sign. So it means go left 2. So we look at each of these. The one that shows left 2 from the parent function is part B. Because again, parent function starts at 0, 0, and then it's moved left 2. And then describe in words the transformation from graph A. So here's graph A. How do we get from graph A to graph C? So how do I get from this graph over to this graph? So if you look at the vertices, that's what I'm going to focus on. This, how do I get from there to here? What happens is we translate. So you're translating this graph down to, so we're going to write that, translate down to, and then you translate 2 to the right to get here at 2, 0. So down 2 and right 2 to move this graph onto C, or to get from A to C. All right, our last problem, number 18, is you can work at most 19 hours per week. So 19 hours, but we can work at most. So this word right here represents an inequality. At most means you have to work less than or equal to 19 hours for the week. That's what at most means. You need to earn at least $105. So I'm going to do the dollars in a different color. At least $105 means you need to earn greater than or equal to $105. To cover the weekly expenses, you can earn $7.50 an hour walking dogs and $4 an hour washing cars. Assume that X represents walking dogs. Let's write that down. Hours walking dogs. And Y is going to represent the number of hours for washing cars. So we're going to choose the correct system of linear inequalities to represent the situation. So the first thing we're going to need to do is come up with a system of inequalities. So I'm going to focus on that money inequality first to put together these 3 numbers. So if I put these together, it's going to be $7.50 for every hour you walk the dog, plus $4 for every hour washing cars, for a total of $105. I'm not going to write equals. I'm going to use the inequality that I wrote above that says you have to earn at least $105. So whatever you earn has to be greater than or equal to $105. Your second inequality is about the hours worked. However many hours you worked washing the dog plus however many hours you worked washing the car has to be less than or equal to 19, because 19 is the most you can work in that week. So for each of these, I want to graph them. So again, what we did on this previous problem is that we are going to need to put these in slope-intercept form. So I'm going to get y by itself for each of these equations so that I can graph over here. So if I do that with my first equation, which I'm going to show you over here, 750x plus 4y is greater than or equal to 105. So what I'm going to do is I'm going to move over the 750x by subtracting to both sides. So 4y is greater than or equal to negative 750x plus 105. Then I'm going to get y by itself by dividing 4, and I get y is greater than or equal to negative 0.750 divided by 4x, and then 105 divided by 4, we can do that work. I actually need more room than that, so I'm not going to do it right there. So we got to be able to do 105 divided by 4. So when I do that, 4 goes into 10 twice. 2 times 4 is 8. Subtract, bring down the 5. 25, or 4 goes into 25 6 times. 6 times 4 is 24. 1. So I have a remainder, so I'm going to add in a decimal, 0, and bring down the 0. 4 goes into 10 twice, so 2 times 4 is 8. 10 minus 8 is 2, and we're going to bring down another 0. 20 divided by 4 is 5. So there it is, something like that. So if I look at these graphs so far, I know one of these equations has to start at 26.25. So it's going to start up here at 26.25 and then have a slope of about down 7.5 over 4. So if I do that, it's going to be a line that's coming down something like this. So I'm going to go ahead and know that it's going to be either C or either B, because it's going to start as a y-intercept at about 26.25. So that only happens in C and B. I'm going to go ahead and cross out A and D. Since this says greater than, I know from this line that starts at 26.5, greater than means we're going to shade above. So from this line, I should be shading above. And so far, that looks like what these graphs are doing, shading above. Okay, so then I'm going to do the same thing. I'm going to take this equation that I came up with, x plus y is less than or equal to 19, and I'm going to put it in slope-intercept form just like how I did with this first equation. So to do that, it's a bit easier. Subtract x. So I have y is less than or equal to negative x plus 19. This has an underline in the inequality, so the line we're about to draw is solid, and less than means you're going to shade below. So my y-intercept is 19. I start at 19, and I go down 1 over 1 over my graph, and I'm shading below that line. And remember, the system of inequalities is where the arrows intersect. My answer is C. The reason why the answer is not B, which is very close, is that this is a dashed line. You only do the dashed line if you don't have the underline in the inequality. So that's how we get C for our answer. And that concludes our practice test. Make sure that you are practicing these problems again and again so that you can do well on your test. Good luck.